In this paper, we present SignAvatars, the first large-scale multiprompt 3D sign language motion dataset with SimpleX mesh annotations. Our dataset is designed to bridge the communication gap for hearing-impaired individuals. Here are some examples of the continuous signs in our dataset. Here are some examples of the isolated signs in our dataset. Our dataset is the first large-scale 3D sign language holistic motion dataset composed of 70K video clips and 8.37 million frames in total. To fill in the gaps of previous 2D-only SL data, our expressive 3D holistic body annotation consists of face, hands, and body, which is achieved by adopting parametric model SimpleX. Our dataset is so far the largest SL motion dataset with the most modalities on both isolated and co-articulated signs. To enable more generic applications for different users, we provide more modalities in our dataset. Our SL annotations can be categorized into 4 common types: HamNoSys, word, spoken language, and gloss, which can be used for a variety of downstream applications such as sign language production and sign language recognition. For annotation, our dataset leverages an automatic annotation framework to collect SL motions in diverse modalities. Given only RGB videos, the pipeline is initialized by a hierarchical process fusing state-of-the-arts like OSX, ACR, and PAIR, which is followed by a multi-objective optimization for fitting face, body, and hand models respecting temporal and biomechanical constraints for hands. Our fitting pipeline is generic to all types of full-body videos and not restricted to isolated sign language videos. Here are some fitting examples of our annotation pipeline. Our method can especially produce accurate hand poses, even in presence of complex and interacting hand gestures. Our dataset enables the applications to generate high-quality and natural 3D sign language holistic motion along with 3D meshes from both isolated and continuous SL prompts, including HamNoSys, spoken language, and single word. We further introduce a transformer-based 3D sign language production baseline trained on our dataset. In particular, we first create semantic and motion codebooks using 2VQVAE and then employ an autoregressive model to generate motion code indices based on semantic codes. Here are some generation examples from different input prompts, where the 2 on the left are generated from spoken language and the 2 on the right are generated from HamNoSys and Word, respectively. Moreover, we can then perform a character-driven 3D sign language production. Here are some generation examples from HamNoSys. Here are some generation examples from word-level English. Here are some generation examples from spoken language. To fully assess the quality of our motion generation, we evaluate the holistic motion as well as the arm motion based on an evaluation model trained following prior arts in motion generation. It can be seen that the 3D with word level prompts can achieve the best performance, reaching the quality of real motions. Learning from spoken languages is a naturally harder task, and we invite the community to develop stronger methods for 3D sign language production from spoken languages. In Table 4 and Table 5, it shows the potential that leveraging our SignAvatars dataset can easily enable more 3D approaches and significantly improve the existing NLP applications by simple adaptation compared to the original hand-to-pose. Moreover, our method drastically improves over the baseline of MDM and ham-to-pose with the interaction of motion and linguistic feature codebook, leading to significant improvements in prompt motion correspondences. In conclusion, we first introduce SignAvatars, the first large-scale multi-prompt 3D holistic motion SL dataset, containing diverse forms of semantic input. Second, to provide accurate annotations for SignAvatars, in the form of expressive 3D avatar meshes, we introduce a multi-objective optimization capable of dealing with the complex interacting hand scenarios, while respecting the biomechanical hand constraints. Third, we provide a new 3D sign language production, SLP, benchmark for SignAvatars, considering multiple prompts and full-body meshes. Finally, we further develop a VQVAE-based strong 3D SLP network significantly outperforming the baselines, which are also introduced as part of our work. Thank you for watching.